Let's continue with 8A.2.1, where we'll introduce some more rules and identities of exponents for complex numbers. We're given two complex numbers, ej theta and ej psi. We're multiplying these complex numbers together, and of course you could have represented this number as a plus jb and this number as c plus jd, and then you could have done the multiplication in rectangular form. But in complex numbers, it's so much easier. We have the exponent are going to be added together when these two values are multiplied together. The base is still e. So we are going to write this as when we are multiplying two complex numbers, the exponents will add. And how did we prove it in the last lecture? Well, you first have to write ej theta as cosine theta plus j sine theta, and ej psi as cosine psi plus j sine psi. And then when you multiply them together, then you collect the term cosine theta, cosine psi, and then the complex numbers are going to be multiplied together to form real j, and j is j squared. So we have minus sine theta sine psi. And then we have the first expression over here. And then we are going to collect the imaginary terms, which is j sine theta multiplying by cosine psi. And then we have this term here plus j sine psi cosine theta. Now, this term cosine theta cosine psi minus sine theta sine psi, this is cosine theta plus psi. What about the second term? Well, we bring the j out, and then we have sine theta cosine psi plus sine psi cosine theta. This is sine theta plus psi. So look up your sum of trigonometric identities and you'll get this. And of course, once you recognize in this form, isn't this ej theta plus psi? So the take-home message is this. In the complex exponential, when we are multiplying complex exponentials together, the angles will add. Okay? And then what about when you have division? Alright, now let's do the division. Well, we're going to write ej theta divided by ej psi as this. And then what we remember is that, well, when we want to divide by complex number, the denominator cannot be complex. So what we do is that we are going to multiply top and bottom by the conjugate of this ej psi, which is sine psi divided by cosine psi minus j sine psi. When we multiply this number by its complex conjugate, we'll get a real number at the bottom, as you will see soon. Let's continue. In the numerator, we open up this cosine theta plus j sine theta multiplying by this term cosine psi minus j sine psi. When we open it up, we have cosine theta cosine psi. Then we have j and j squared, which is minus 1. So minus 1 and minus become plus. So we have sine theta sine psi. So we have the first term here. And now let's collect the imaginary term, which is j sine theta cosine psi. And we have minus j sine psi minus j sine psi multiplying by cosine theta. So the numerator is here. The denominator on the other hand is cosine psi cosine psi. So it's cosine squared psi plus j squared. So it becomes minus, so plus j squared becomes plus j times minus j becomes plus sine squared psi. So the imaginary part goes away, and the denominator, this expression of course is equals to 1. So we are left with the top expression, and then we remember the identities of trigonometric at some angle, cosine theta cosine psi plus sine theta sine psi. This reduces to cosine theta minus psi. And what about the bottom one? Is plus j. So sine theta cosine psi minus cosine theta minus psi is j sine theta minus psi. And of course, this reduces to ej theta minus psi. So the division in complex exponential is very easily realized by saying that the angles of the numerator is subtracted to the angles of the denominator. Okay, and then the rest of the expression follows. If the numerator is 1 and the denominator is e to the power z, then it reduces to e to the power minus z. And also if we multiply ej theta times 1, then ej theta times its complex conjugate e minus j theta, then the angle theta plus minus theta becomes 0, so e minus j0 equals to 1. Alright, so the rest of the identities follows. What about ez to the power 2j? Well, we'll do it as e to the power z times e to the power j 2 pi. Now j 2 pi is 1, so this reduces to ec. What about ex plus iy? So this is ex times eiy, and ex is a real number, eiy is cosine of y plus j sine of y. And then we can open it up, and then we can collect the real terms. Ex times cosine of y as the real term, ex plus I sine y is the imaginary term. Alright, so with that, I think you can figure out that some of the questions involved when we are doing multiplication, you'll be better off to do it in complex exponential form, remembering that the angle is adding, and if it's division, the angle is subtracting. With that, thank you very much.